In this example, we'll use substitution to solve various systems of equations. A quick inspection of the equations in part A shows that it would be very easy to isolate x in the first equation. Just bring minus 2y to the right side and you're done. Substitute minus 2 plus 2y for x in the second equation, as shown in the animation. Multiply 3 through the brackets on the left side. Collect the terms with y on the left side and collect the constants on the right side. This gives 5y equals 10. Divide both sides by 5 to get y equals 2. Now we'll plug our y value of 2 into either equation to solve for x. In this example, we'll use the first equation, x minus 2y equals minus 2. Plug in 2 for y as shown in the animation. Simplifying, we get x minus 4 equals minus 2. Bring minus 4 over to the right side to get x equals 2. The point of intersection for this system is 2, 2. In part B, we have the equations x plus 6y equals minus 29 and x plus 1 over 4y equals minus 6. We'll isolate x in the first equation by bringing 6y to the right side. This gives x equals minus 29 minus 6y. Substitute minus 29 minus 6y for x in the second equation, as shown in the animation. The brackets are no longer needed, so remove them before we solve for y. Collect terms with y on the left side and constants on the right side. We need a common denominator before we can combine minus 6y and 1 over 4y. Write minus 6y over 1 and multiply top and bottom by 4. This gives minus 24y over 4 plus y over 4 equals minus 6 plus 29. Simplifying gives minus 23y over 4 equals 23. Cross multiply to get minus 23y equals 92. Divide both sides by minus 23 to get y equals minus 4. Now we'll plug the y value of minus 4 into either equation to solve for x. In this example, we'll use the first equation, x plus 6y equals minus 29. Plug in minus 4 for y, as shown in the animation. Simplifying gives x minus 24 equals minus 29. Finally, we get x equals minus 5. The point of intersection is minus 5 minus 4. In part C, we have the equations x plus 3y equals 3 and 3x plus 9y equals 9. We'll isolate x in the first equation, bring 3y to the right side, giving x equals 3 minus 3y. Substitute 3 minus 3y for x in the second equation, as shown in the animation. Multiply the 3 through the brackets. When we attempt to solve for y, we end up with 0 equals 0. What's going on here? If x plus 3y equals 3 is multiplied on both sides by 3, it becomes 3x plus 9y equals 9. This is identical to the second equation. The two lines will lie directly on top of each other, yielding infinite solutions. In part D, we have the equations 2x minus y equals minus 13 and 2x minus y equals minus 1. This time, it is easier to solve for y in the first equation. Bring the 2x to the right side, then divide both sides by minus 1. This gives y equals 13 plus 2x. Substitute 13 plus 2x for y in the second equation, as shown in the animation. Distribute the minus through the brackets. Attempting to solve for x results in 0 equals 12. The first and second equations have exactly the same coefficients but different constants. When converted to slope-intercept form, they have identical slopes but different y-intercepts. These lines are parallel and have no solution.